To further continue, after electric vehicles and hybrid electric vehicles, we are going to see the diagnostics which govern, or we are going to see the standards which govern the diagnostics for heavy duty vehicles. So to proceed further, heavy duty vehicle diagnostic refers to diagnostic systems, protocols, and regulations designed specifically for heavy duty vehicles such as trucks, buses, and construction equipment. Now, unlike light duty cars, light duty vehicles, SUVs, heavy duty vehicles require specialized standards and tools due to differences in architecture, use cases, and emission requirements. This domain is primarily governed by J1939 standards and heavy duty onboard diagnostic regulations. J1939 protocol, the backbone of diagnostics. Now, what is this J1939 protocol? So, this a protocol is a high layer communication protocol based on CAN used in commercial vehicles and heavy duty equipment. It enables real-time communication between ECUs, that is electronic control units. Now, what are the key characteristics? First is this is standardized by SAE. It is built on control area network, acronymed as CAN, and it uses 29-bit extended CAN identifiers as opposed to 11-bit mainly used in light duty systems. So understand this, in heavy duty it is 29-bit and in light duty it is 11-bit. And also it is designed for modular multi-ECU architectures commonly found in trucks and buses. Okay. Now, what are the major applications? Major applications is engine, transmission, brakes, ABS fuel system, body control, telematics, emissions, diagnostics, and prognostics. These are the major major applications. Now, when it comes to J1939 protocol, the message structure, when it comes to message structure, the part of the message structure, PGN stands for parameter group number, identifies the message type. SPN, suspect parameter number, identifies the individual parameters like engine speed, fuel temperature. Message parameter priority, source address, and destination address. Okay. Now, when it comes to diagnostic functions in J1939, first supports the J1939 supports the diagnostics via the following procedure. First procedure is DM message, which is diagnostic message, and these messages are standardized across heavy duty systems to support diagnostics and troubleshooting. All right. So see this DM1 is active diagnostic trouble center double code. DM2 is previously active diagnostic trouble code. DM3 is diagnostic readiness information. DM4 is supported SPNs. DM5 is emission related DTCs. DM11 is clear DTCs. DM12 emission related active DTCs. DM20 monitor performance ratios. DM21 freeze frame data, and DM24 supported diagnostic trouble codes. So these are all the various messages, diagnostic messages, and their respective description. Okay, and one more thing to be noted is each DM message follows a structured format and is accessible through the diagnostic tool connected to J1939 bus. Now, when it comes to tools for J1939 diagnostics, first is HD high definition scan tools. Okay, so J1939 compatible diagnostic scanners, ECU reprogramming tools, OEM specific tools to update the firmware. And when it comes to telematic gateways, the remote diagnostics and predictive maintenance. All right, the PC-based diagnostic software Cummins Insight. When it comes to PC-based diagnostic software, Cummins Insight, Detroit Diesel Diagnostic Link, and softwares like Texas, Jaltest are under the category of PC-based diagnostic software. Now, when it comes to heavy-duty OBD regulatory view. Now, what is this heavy-duty OBD? HD-OBD is a regulatory requirement for heavy duty vehicles similar to OBD2 for light vehicle. It monitors emissions critical systems and ensures that malfunctions are detected and reported via DTCs and mm, MIL, malfunction indicator lamp. Now, when it comes to regulatory framework, USA, which is a combination of EPA and CARB, it is mandated by EPA, Environmental Protection Agency, and CARB, which is acronym for California Air Resources Board. Now, required for diesel engines, it is required for diesel engines, especially when their gross vehicle weight ratio is exceeding 14,000 pounds. And based on J1939 with HD-OBD specific messages, it requires emission system monitoring, which monitors NOx, particulate filter, secondary catalytic reduction, and exhaust gas reduction. Sorry, exhaust gas recirculation. And also it requires mill activation, readiness monitors, in-use performance ratios, and DTCs per SAE 2012 DA. Now coming to standard connector 9 pin or 16 pin or J1962 style. Okay, so these are all regulated or governed by this USA EPA plus CARB. And when it comes to Europe, okay, Euro 6, right now Euro 6 norms are prevalent and worldwide harmonized OBD and HD-OBD. Let's see what falls under this. It is governed by Regulation 2018 and Euro 6 uses WWH OBD standardized ISO 27145. And when it comes to UDS, Unified Diagnostic Services, ISO 14229 over CAN or IP. It requires standardized diagnostic communication, emission related component monitoring, global standard DTCs, ISO 15031, SAE J2012 readiness and IUPR. All right. So to further proceed, what is the difference between light duty OBD? Light duty OBD and heavy duty OBD. So when it comes to the protocol, for light duty OBD, the protocol is ISO 15765, and for heavy duty, it is J1939. But both are CAN based. But as I said, heavy duty for it is 29-bit and light duty it is 11-bit. Now addressing, it is 11-bit ID and 29-bit ID, which I just now spoke about. And diagnostic standard is OBD2 SAE J1939 diagnostic messages. Emissions focus is catalyst evap EGR, and when it comes to heavy duty, focus is on DPF, SCR, NOx sensors, EGR. Now regulation bodies EPA and CARB, and heavy duty again EPA, CARB, and also European regulatory bodies. And when it comes to light duty, the physical connector is 16 pin, and for heavy duty it is 9 pin. Okay, now what are the key diagnostic use cases? When it comes to key diagnostic use cases, reading live parameters, engine RPM, fuel rate, coolant temperature, and when it comes to reading clearing DTCs, DM1, DM2, and DM11. Now, considering this monitoring emission systems, DPF loading SCR efficiency, and in-use performance tracking DM20, and freeze frame analysis DM21, and reprogramming ECUs. Okay, even when reprogramming ECU, it is a diagnostic use case, and also productive maintenance and prognostics. So these are the various types of use cases when use cases of the key diagnostics. All right. Next, when it comes to example workflow for J1939 diagnostic tool, the connector tool for 9-pin J1939 connector, send request for DM1 active DTCs, tool interprets SPNs and FMI. FMI stands for failure mode identifier, and technician uses SPN FMI code to determine the failure and clear DTCs using DM level after repair. So this clearly shows the workflow, exactly how when you use the J1939 diagnostic tool, what are the various steps that follow one after the other. And optionally, monitor live SPNs or perform special tests. The last step is optional. All right. So in summary, When it comes to heavy duty vehicle diagnostic, it revolves around J1939, it revolves around DM messages, it revolves around HD-OBD and global compliance, which is governed by the EPA CARB or WWH OBD, and also tools like specialized 1939 CAN tools, OEM software, telematics integration. Okay, so I hope all of you got a clear-cut idea about the diagnostic regulations or diagnostic protocols exclusively for heavy-duty vehicles.